Put on my DJ voice. All right. Let's go ahead and get started. So, welcome to the Northern Virginia Linux Users Group. I see a couple of new faces, I think. You're new, right? Have you been here before? Do you like me like pointing people out either? Yeah.
It's probably been 10 years.
So not new, but.
NoVaLUG attendance started in about 98 with the DC lug. So,
Is DC Lug still going on?
no.
That's unfortunate.
The old contingent.
All right. So everyone should have signed in. I think everyone did. And if you want to get on the Wi-Fi, that's it. It's also written on the whiteboard back there. If you got a parking ticket from the parking deck, make sure you validate it before you leave so you don't have to pay for the parking. And many thanks to Ridgeline for hosting us. Thank you, Ridgeline. So, again, the Wi-Fi password. Anyone need this? I think most people already have it. All right. Just to remind everyone, this meeting is being recorded and being streamed. So, don't say anything about your employer, especially you, Bryan, that you don't want to be made public. All right. We do have meeting notes, which you can go there, links.novalug.org/notes. And so a lot of the things that the information that I will be presenting are already in the notes, especially the URLs, in case you want to follow them. Also, it's a collaborative workspace with HedgeDoc, so you can go ahead and add notes if you want, including to the main presentation. So, just a couple of things we always say or always give out are links to NoVaLUG itself. So we have a website, we have a mailing list. We're on Mastodon, which is where I normally do most of the presentation or the announcements. There's Discord. How many people are using Discord? It's mighty silent. Oh, well, at least 3. Yeah. Okay. So, and then LinkedIn. How many people see our stuff on LinkedIn? Nobody? Well, oh, 1. Okay. All right. Cool. Anybody use Signal besides me and Tim? Might start a Signal group because that might be better. Discord, I know a lot of people who do gaming use it, like my son, but our Discord stuff seems to be kind of barely used. Let's do some icebreakers. So this week's, remember last month's icebreaker where I did a bunch of like Linux trivia questions and they were semi-hard to answer, right? So this month, what I decided to do was ask Google's AI for Linux trivia questions. Basically, actually, I said geek computer trick questions. And so let's see if you can beat the AI, okay? All right. All right, so what's the only thing that can be broken in a computer by typing break on the keyboard?
Code.
Nobody? Code? That's close. So, a break statement. All right. What's the most important key on the keyboard and why? And by the way, I did not alter these answers. Or the questions, actually. You know, that would be a good answer. But for whatever reason, the space bar. So, all right. What's the difference between a bit and a byte? Would you say 8?
Whatever, I was going to say whatever makes more sense to marketing.
This is, yeah. So Tim, so far you're beating the AI. This was a pretty bad. I thought this one was pretty bad. And by the way, as I was doing this,
Oh no!
as I was doing this, I kept trying to. I apparently suck as being a prompt engineer because I couldn't get the questions any better. All right. So what's faster, a 1 gigahertz processor or a 2 gigahertz processor?
Follow-on question.
Yes.
What era? How many cores? How many cores? Is it Intel or AMD? What memory? I vaguely remember my 1 gig AMD outpacing my Intels. So
There you go. Well, according to Google's AI, it's a 2 gigahertz processor, so all that stuff you said was irrelevant. All right.
sounds right.
All right. What can run but never walks, has a mouth but never talks, and has keys but no locks?
The riddle of this one isn't even computer related.
Yeah, I'm curious about the mouth.
I mean, don't my computer has a mouth, so
Are you talking about a speaker?
I have no idea. I have no idea where.
What you do with your computer on your own time is your business.
What you do in the privacy of your home with your computer is, yeah. What stays in Vegas happens in Vegas stays in Vegas. Okay. I have keys that open no locks. I have space but no room. You can enter but you can't go inside. What am I?
Oh, that's not accurate. I go inside my keyboard all the time.
Keyboard, that's right. You're like people who do mechanical keyboards, they open them up all the time. All right. I think we're at the last one here. I have directories. No, I'm not. I have directories but no houses. I have files but no paper. I have users but no bodies. What am I?
An operating system?
Oh, wow. You guys are beating the AI. Or you looked at the agenda slides, which are online. All right, last one. I have no physical form, yet I can cause chaos and destruction. I have no voice, yet I can scream warnings. I have no feelings, yet I can evoke fear and frustration. What am I? Oh, a virus would have been a good one, but no, AI. System error.
I feel
So,
like this could encompass many different people, but
oh yeah, coworker. Yeah.
sure.
All right, so I'm not impressed with the AI trick questions. So anyway, hopefully that got everyone thinking.
Have you seen the recent one over like the last couple of days? There was a grad student using Google Gemini to help with their paperwork or whatever research doc they're doing, and it responded that you should kill yourself.
Ooh.
Yeah.
Apparently the guardrails for Google's Gemini or Bard, whatever they call it, is not good enough then. Wow, that's pretty bad. The I've started thinking about, I'm gonna, like, when people start having Slack conversations with me at work, I might start using the AIs to like generate walls of text so they can quit talking to me. But anyway, I shouldn't have said that. Tech news. All right. So again, all the URLs are in the notes if you want to look at them. So Bitwarden. Anyone remember what happened with Bitwarden last month?
I remember seeing something in the news about it.
So they got taken out of one or two distros because their SDK actually was not an open source license.
A certain part of like a certain SDK or something like that.
Yeah, so someone noticed. Apparently, it's been like this for a long time, and someone finally noticed. And so there was one of the maintainers, one of the distro maintainers, said, "Sorry, not doing this anymore." It caused a big controversy. Well, they just changed it to GPL, so it will be back in. Not sure what happened there, but so Bitwarden is now once again open source. So it was pretty interesting. Yeah. I mean, good luck with this. But, I mean, the U.S. government does a lot of things. So calling for the end of this, actually, I think that was more or less the headline, the clickbait headline. They are trying to get people to quit using C and C++. So, and that came from CISA and the FBI. The FBI is well known for being on top of things.
Yeah, I'm
So.
looking forward to every project out there moving to Rust overnight.
Could happen.
There's a lot of sarcasm in that comment.
Yeah, well, thanks for remembering safety, but like it is hard, I will say.
Isn't the accounting software in California still running on Fortran?
Oh god.
Probably COBOL.
There is
So, yeah.
So, there's going to be C and C++ for the foreseeable future.
Yeah. Yeah, I don't think it's going to be removed from anything anytime soon. And I'm a big Rust. I actually love Rust, but I don't think it's. I think this is kind of like extreme wishful thinking. So, RISC-V. So I did not know this. So inside of a lot of the NVIDIA graphics cards, they have their own microcontrollers in there. And they're called the Falcon microcontrollers. They started this a number of years ago. They decided they didn't want to be maintaining their own instruction set. So they've been switching to RISC-V. And they just announced that this year they're going to be shipping 1 billion RISC-V cores in their products, across all their product lines. So you can't go like, I don't think you can access them, but I thought this was pretty interesting that that RISC-V is going to be in like 1 billion NVIDIA products. So.
That seems like the logical choice, given that they tried to buy ARM
Yeah.
ago. So everybody figured they'd pivot towards risk.
So well, yeah, I mean that is interesting. That's a good point. That they tried to buy ARM, and so I don't know if they were going to go to an ARM product. Maybe that's why they went with RISC-V, and that
That's
fell
what
apart.
They wanted to be able to, I'm trying to remember what it was called, whatever the bundled product was with the H100, they wanted to ship with an ARM-based CPU to replace AMD and Intel outright, but the whole thing fell apart when everybody complained.
Yeah,
Well, that was more than that, but yeah.
when everybody, including the U.S. government, complained. All right, speaking of RISC-V, they just ratified so RISC-V International just ratified the RVA 23 profile. I did not know what I'd never heard of this, but apparently it's a big deal in the RISC-V world. So RISC-V has a bunch of different, I guess, standards, for the instruction sets. And so what they've done, it was kind of getting confusing to people. So what they've done is they've created this profile called RVA 23. And it has not just the standard CPU type of instruction architecture instructions, but also vector and some other things that are good for AI. So, and atomic instructions, which are really good if you're trying to do multiprocessing and multitasking. So, anyway, so that's kind of cool. If anyone is interested in RISC-V, you can go look at the link for that. Speaking of processors, ARM is now threatening to cancel Qualcomm's contract or their license. And this I thought was kind of interesting because so the Snapdragon Elite falls under this license. Qualcomm bought NuVia a couple years ago, and they're the company that had all this IP and stuff for ARM processors. And so ARM is threatening to cancel the license, which means if they do, the only real competitor to a Mac is going to be nothing. So they should have.
Why isn't the RISC-V an alternative?
I mean, if I were Qualcomm, I would be doing that today. I mean, it probably takes a lot to
I was gonna say
to engineer the cores. So RISC-V is just even though there are open source cores as well, but RISC-V itself is just the instruction set architecture.
I would say that it's an investment in infrastructure. Qualcomm has a lot of money in ARM right now, so, and as nice as RISC-V is, like, it's not as mature as ARM is. So if Qualcomm shifted to RISC-V, it would
Take a couple of years.
before it would.
I'll bet you they have a group inside of Qualcomm right now looking at this.
I mean, I may have misread the news article, but I was under the impression that they had notified them that they will cancel it.
Oh, that's pretty bad.
Qualcomm has already, like, it's a 30 or 60-day notice before the license is canceled. Qualcomm has to fight it in court at this point.
Wow.
So,
What terrible thing did Qualcomm do to qualify for this?
ARM claims that they misused licensing from a purchase of a subsidiary.
Yeah, it's
So it's basically a license spat.
this comes down to money. I mean,
Yeah, pretty much.
it comes down to money. Like they're using a license that they're using their license for a product that ARM generally would charge more for. So that's what it comes down to. Well, I mean, so it's a good cautionary tale. People who are investing in ARM intellectual property probably want to start considering whether that was a good idea or not. So, and I thought this was interesting. So, speaking of a Virginia news story, the Institute of Justice, I know it's running off the page, whatever. The Institute of Justice is suing the city of Norfolk, Virginia for mass surveillance using traffic cameras. I thought that was a pretty interesting story. I don't really have anything else about that, but I thought it was kind of an interesting story where people got together and said, hey, you know what? It's not really cool that the city is, or the government is using traffic cameras to spy on people in such a way. So we'll see where that goes. What?
Good luck to them.
I don't know. I mean, the Institute for Justice has a pretty good track record of beating the government. So the governments. All right. I don't really have any area events this month. So if you do, you can go. If you know of something, anyone know of anything that's going on? The Maker Faire was last month, but as we get into November and December, things are. Did you go?
Yes,
Was it good?
yes, it was.
Oh, good. Anything we should know about, or?
No, there was all kinds of things from like crafting and things like that. There was some electronics there. Some of the one thing I found interesting was a couple of the animatronics folks from, they were doing like, they had done some work for some of the Lucasfilm stuff, so they had like the life-size models there, and a couple of the models, you know, there are D2s and the BB6s, 9s, whatever it is. So that was kind of cool, but that was very much very professional, if you will.
Yeah.
But really, really kind of cool. They had a BB-8 robot there, and you know the whole problem where it's a spinning thing, and they have this gimbal inside of it. It's basically magnets to keep his head where it should be on the ball.
Really?
It was really cool seeing the guts of that.
Wow. So it actually worked, like it would fall off or anything?
No, like I said, it was this weighted gimbal, and the thing stuck up, and it was magnetic, and the thing would be on top, so it would spin, the whole ball would spin around it, and that's what would keep the head up top.
Interesting. All right. Any other? If you know of any area events, go ahead and put them in the notes. I'm going to put this up. Call for presentations. So if you want to present here at NoVaLUG, please let me know. Again, we don't really have any standards. Yeah. So it can be from anywhere from 15 minutes to an hour and a half. If it's a shorter presentation, we'll fill up the time. And the scope is really anything that's kind of open source or open knowledge related. So it's not strictly Linux, although we do like Linux presentations. But if you know of any open source software you want to talk about, or anything that that people can come in and get their hands on in an open way, that would be great. Polishes any way you want. You can come in and just open up a terminal and start doing terminal commands if you want, or you can have a highly polished. You can bring in your marketing department. No one's done that yet, but if you want to do that, just let me know. See me after the meeting, and I'll try to schedule some time. What we do have coming up, so next month, we're going to try to do an install fest and a swap meet and a geek t-shirt contest. So we're not actually having a presentation. So next month, if you have any gear, I have like 2 keyboards I want to bring in that I would like to part with. But if you have any gear you want to part with or anything like that, and if you have anything that some extra gear people can install Linux on, I'll probably bring a Raspberry Pi 5. We'll do that next month. Plus, we're going to have a t-shirt contest, not a wet t-shirt contest. So in January, we have a speaker from AWS coming to talk about AI. He was one of the guys, if you remember the talk we had in April, about AI security. He was one of the guys in the audience that was peppering us with a bunch of questions. So he's going to be back talking about that. In February, we have Professional's Guide to IPv6, and March is open at the moment. Although I'm probably going to ask Matt if he can talk about his laptop recycling business, where I did not know this, but he has a side hustle where he's refurbishing Lenovo laptops and putting Linux on there and selling them. So that seems kind of interesting. So the other thing is, you may have noticed that we've had a bit of a drop-off in attendance since we quit using meetup.com because we don't like to pay $400 a year or whatever it is they're charging. So that what we want is to find a way to kind of get the word out that we're still here, we're still around. So if you have any ideas, I would welcome them. If you have time to help go knock on doors, I don't know, whatever it is, I would welcome that as well. So, and here's our main presentation. So Bryan, I've known Bryan for 25 years, a long time. Bryan is the co-founder of his own company, Cobenian, so he can shit talk his boss all he wants. I, in my professional career, have relied on his company 3 or 4 times already at this point to help us get out of jams. So he runs a company that where he does basically software development. and he's been using AI so to kind of help with that. So as opposed to like the hype about AI and how you can use it, which there is a lot of, he's got a lot of practical, real world experience, and that's what this presentation is about. So Bryan, take it away.
Is my mic on? It's good. Okay. Thanks for the introduction, Andy. This presentation, when Andy said, "Hey, can you come talk about AI?" I thought, well, there's a million different ways, right? Different things I could cover, right? Do we want to talk about the deployment to, we deploy to, Docker containers. We use Linux in production. I'm actually not going to cover any of that. I didn't want to come here and talk about ChatGPT prompt engineering, so this is absolutely not a ChatGPT talk. We're not going to do that at all, right? And so I had the idea of, well, we could take a deep dive into one area, but the problem is there's so many areas in AI that taking a deep dive in one area wouldn't really allow you to get a feel for what's going on. So we have people with varied backgrounds here. So what I thought is I would do a little bit of sort of a survey of the AI space right now from a software development point of view. I'm a software developer at heart, right? That's what I do all day. I have to do accounting and some stuff because I have my own small business, but I really write software all the time. So this is an interactive presentation. I have 9 examples. It's all available in a GitHub repo, so you can read the code later on. Feel free to stop. This should be interactive. Stop, ask questions. You don't need to wait to the end to raise your hand. Because I have 9 examples, though, there may be times where I just say, hey, we need to move on to the next example. Of the 9, if there's one, excuse me, that's particularly interesting, we can also come back to it at the end. If everyone's like, hey, we really want to talk a little bit more about this one of the 9. But I would like to make it through all 9. So I apologize in advance if we start getting into one. But like I said, we can come back to it at the end. And so, AI, there's a million buzzwords. There's a million libraries. It's changing every week. I originally was going to put up some slides in one of the slides, but I said, I'm just going to jump right into it instead of having slides. One of the slides said, I prepared this presentation. You could see here in the Git history, right? 4 days ago was the last commit to this repository, right? So that means that everything in here is out of date already in the AI world, right? That's what it feels like right now in AI. And then I also am a big believer, right? I could show you 9 hello world examples. That's not particularly interesting. So I said, how can I tie these 9 examples together? And so what I decided to do was say, I need to have one story, right, that sort of ties a thread through all of the different examples. And so what I did is I can't show code that I've written for clients for obvious reasons. So I said, I need to come up with something that everyone will be able to understand. And so I have 2 sons. One of them's here. They both play baseball. Baseball is important in our lives. So I decided to use a baseball example because I think everyone understands enough about baseball to follow along with these. We're not going to get into, statistical analysis and different things like that. We're going to, sort of keep it at a really high level. So I am using an open source vector database called Weaviate in this demo. So I have that running in a Docker container locally. I am, for a couple of these, using Anthropic's API, which is a commercial product that I pay for. It's a competitor to OpenAI's ChatGPT. We've found that it's much cheaper than using ChatGPT. So if you do want to make API calls to an AI, we tend to use it on our projects instead of OpenAI. I'm not here to plug one versus the other. I'm just saying from our point of view, the same reason that in our containers, we write a lot of Elixir code. We don't run a lot of Java because when you run in the cloud, Java tends to be much more memory intensive. Compute and disk tend to be pretty cheap in the cloud. Memory is very expensive. So we tend to operate with Elixir, Rust, things that are much more low memory footprints. It saves our clients a lot of money when we're running in containers in the cloud. So what's the backstory, the sort of thing that's going to tie these 9 examples together? So basically, I've set up this little made-up scenario here. It says, oh no, the old coach of my son's baseball team's moved out of town, and I've been tasked with taking over the team. I don't know really how to coach a baseball team, right? So I'm going to have AI learn how to coach and use various tools to help me coach this baseball team, right? That's sort of the thread that we're going to tie through here. So the very first one is basically, these baseball players, they know, oh, hey, I'm a right fielder, I'm a first baseman, I'm a catcher, right? They know I'm a pitcher. They know their position. But what they all want to be the, hit first, second, or third. Like, oh, well, where do you hit in the lineup, right? We're going to have a big argument. So what I said was, well, what would be interesting is if we could take the stats from the previous season, right? I don't have all the stats, but enough of the stats. Go ahead and find some fair way to put together a lineup for the hitting order, right, that they're going to bat in. In the README, I have all of these instructions. They sort of say like, hey, here's what to run. And we can take a look at the code, especially in the places where you want to take a little bit of a deeper dive. But then I also explained what the libraries or tools that this example uses, and then sort of what the concepts, what did we learn, what the concepts were here. So let's just go ahead and run this. And let me clear this out. And make this a little bit bigger. And so we're going to go ahead and run this, right? And you can see here that it's said, here are your hitters 1 through 9, and then the rest of the players will be on the bench, right? So, and it shows here, because this is machine learning, right? It shows the predicted OPS versus the actual OPS, right? The other thing is, because we have the actual data, we can check how accurate were these predictions. So let's go ahead and look really quickly at the code for this. So this one is this file right here. And so basically, we go ahead and we take a CSV file with all the baseball statistics. So there's a website that most baseball teams use across the country that keeps track of their stats. So every time there's a pitch, someone enters, it was a ball, it was a strike, or there was a single or a double or whatever. So we legitimately have all the stats. So all we do is, just like I said, we go ahead and we take the data, we go ahead and drop the batter's name, the OPS, the slugging, and the on-base percentage. And we've trained a model, which we'll look at a few lines up above, and we make a prediction for each. It's a two-dimensional, right, data structure. It's a data frame. So we go ahead and make a prediction for every single player and say, oh, yeah, here, based on all their numbers, here's what this library predicts will be their OPS. And then we just sort them so that the highest OPS is first, and we go ahead and show these are the batters. Yes?
Did you write this code, or is this coming from AI somehow?
So, okay, very excellent question. It's actually a combination of both. So this text editor is called VS Code. And if I was to click over here on the right, you'll see GitHub's Copilot, which is an AI for helping you write code. So I could come over here and say, whatever, pandas. Right, so if I ask it some question, any question, right, it's going to come back and it's going to go ahead and show me the example, right? And it's actually, if you look down here, you'll notice that it knows what file I currently have open. So it's using that file as context. And so it's giving me like real examples here, and it puts code, and there's a copy button, and I can copy and paste it over here. What I also love about this, and where this is super, super awesome, is when something goes wrong, I can copy the stack trace out of the terminal, throw it over here. The thing that I type the most into this is, how do I fix this? Enter, enter, and then paste the error message from the terminal. And it's really, really shockingly good about telling you, oh, hey, you're using the wrong version, or like, this library and that library are incompatible or whatever, or what you need to do to fix the code is this. And when you use an AI to generate code, it's never 100%, I won't say never, it's very seldom 100% right. So it takes experience where you can say, hey, go ahead and generate me some code to do this. It's pretty good at that. And sometimes you'll look at it and say, oh, that's pretty good, I can just use it. Sometimes you'll say, oh, no, that's not quite right. And you can tell it, that's not right, I want it to do this too. And it will go ahead and generate more code. It's getting eerily good at doing that. The answer is it's truthfully a mix, right? Like I have an idea of what I want to do. I come over here, have it generate pieces for me. And then, there's a file in here, instructions. This documents what I did, like as I was preparing these 9 examples. Hey, I have to install this dependency. And I literally just wrote down step by step. Here's all the different things I did. And you'll notice at one point, I got this error message right here, right from the library XGBoost, the gradient descent, gradient boosting library, that we're using here. And so I, like I said, I copy and pasted that, said, how do I fix this? And it says, oh, you don't have the libomp library installed. Go ahead and poetry install, brew install, libomp. And boom, all of a sudden that error's gone, right? So it's really, really speeds up your development. Yes?
What AI is the Copilot talking to?
Okay, that is GitHub, which is owned by Microsoft.
Right.
So it's GitHub's Copilot.
I think they co-license from ChatGPT or
Yeah.
something like that.
So I think what's important is it's trained on all of the open source repositories in GitHub. And it's also what's called RAG. So it's also aware of your local context, so your local files. So I mentioned it knows the open file that you have open. So it's a commercial product, but it is phenomenal, and it makes developers like 20 times faster. Both in terms of looking up errors, right? Like I couldn't tell you the last time I went to Stack Overflow and said, oh, let me find this error, right? I don't need to anymore. I just ask this, and it gives me, 90% of the time, it gives me. What you need to be careful of is when it generates code that's subtly wrong. And that's where when you have inexperienced developers versus experienced developers, that makes a big difference, right? Because when you pile on AI generated layer after layer after layer after layer, it can get really hairy, right? It can get pretty nasty. So it's important that you still have someone who understands how all the libraries work and how all the tools work. So.
I would also add, if you're using this in a work environment, make sure you check your company's policy on security and governance. And I can speak that there are certain contractors that you don't want to be dumping your code into Copilot.
Yep. There are also models that are open source that you can run locally. So one of the things that I have, it's going to be really hard to tell, but I'm putting it's called Olama, and it's okay. So you can run LLMs locally. So you can go out to. I love these questions because this is actually helping cover all the different things. So there's a community-based website called Hugging Face, and Hugging Face has open source models and data sets on it. So it's sort of, you can think of it as GitHub for AI, right? So when some AI model has been generated, if people want to make it open source, they can put it up here, and they do. And the same with data sets, right? If you want to say, oh, hey, I have this model I need to train, but I need the data, you can also go out here and get a data set so that you can train your AI model on an existing data set without you having to do all the work of going and collecting. Because anyone who's started in AI, right, like you get tired of the hello world example in AI is like identifying flowers based on petal width and stuff. It's really boring, right? Like the data set's already prepared. You download the data set, run this hello world example. It's very dull. I will say that on Hugging Face, I have found this particular page, the tasks page, to be super helpful in understanding what sorts of things are available. So it breaks it out into like, hey, here are the models categorized by what you want to do. So if you're like, hey, what I want to do is I want to do, text classification, you can come here and you'll find it under NLP, the NLP section, right? They also have computer vision section, audio section, and then it's a little bit misleading because for whatever reason they've decided to put tabular and reinforcement learning on the same line as audio. Those should actually be down. They're their own categories, right? It's just that for real estate reasons, they put them on the same line. But what we've just looked at, right, that example that I just showed with the OPS, right, predicting what the OPS, would anyone care to guess what sort of model, right, that is? What sort of AI problem is that? Does anyone know? So it is a tabular regression. So, right, tabular, right, so it's two-dimensional data, like a spreadsheet. And its classification is, we have a finite set of like classifications, right? And I want to say, like, I can look at a picture of an animal and I could say, is that a cat, a dog, a bear, right, or whatever. And so it belongs to one of these categories, right? Versus a regression, which is I'm calculating a numerical value, right? And it has to do with, right, so in our case, like the OPS, it's really obvious, like, oh, hey, yeah, that should be a regression. It's not, but if I was to say, if I was to try to say, for example, look at data and predict what position a player played, then that would be a classification because I'd be classifying, are they a first baseman, second baseman, shortstop, third baseman, et cetera. So we used, and then I will get into this here, in the tools used in that example, right? We used 3 tools. So we used Pandas, we used scikit-learn, and we used XGBoost. So Pandas is a library for data frames, right? That is a library for that two-dimensional data. So when you have your CSV file, your spreadsheet or whatever, that's the library that allows you to load that data and then manipulate it. So for example, in the code, when we come back over here into this example, I said, hey, I just want to drop some columns in that data, right? I don't want the OPS, the slugging percentage and the on-base percentage to be there when I do the machine learning, right? Because if it is, then it's gonna know the exact answer because the answer is already there. So I take out the data that we're predicting. When you do these regressions and classifications, the thing that's important to remember is when you collect the data, you need to have the answer. You can't train a model if you don't know the answer. So you can't say like, I would love to predict the snowfall, right, in the Andes if you don't have previous data on the snowfall in the Andes, right? You need to have historical data with the answer so that you can train the model. And once the model's trained, then you can make future predictions.
That's not how the internet works.
So no heckling from the front row. Are there any more questions about this? I know I'm sort of, I guess I should point out here too, this is the function that does the actual training, right? So we go ahead and we read in the CSV file that contains all the hitting statistics. A few of them we need to coerce to a better numeric type, right? So maybe it is 73% and it has the percent sign. And we just need to coerce it so it drops the percent sign and just keeps the 73 because we want all numeric values when we're going ahead and training the model. Like I said, we drop the columns and then this Y, so we split the data into test data and training data, right? So we can train a model and then we can use some of the data to train the model and we can use the rest of the data to go ahead and test, is our model any good or not? And then it's an iterative thing and it makes a model that's better and better and better until we get to a point where we say, hey, this model's pretty good, we can go ahead and use it. But this Y, right, this is saying what is the column that we want to predict, right? So it's saying, hey, I want to predict OPS. And so it knows, hey, here are the real values that I need to compare against to see if the predictions were any good. I mentioned that this is not a classification, but it's a regression. So we use XGBoost's regressor. And we go ahead and we fit the data, make our predictions, And then at the end, we do we created a data frame, which is that just XY two-dimensional data structure. And we have the comparisons of, hey, here were the actual values and here were the predicted values. How good were they? And then we can calculate the mean squared error to figure out, were they good or were they not good? Yes?
So the question I have is, you're saying you're predicting the OPS from the data you have there. I thought OPS was a formula.
It is, in real life.
I'm curious what you mean by prediction in this case.
Okay, so in this case, what I'm saying is, imagine that we didn't have it, right? You need it to train the model, but as the season goes on, OPS isn't a great example because it's actually such a simple formula, right? But if the rest of the data we did have, but we didn't have OPS in the future, we could actually make predictions of OPS just based on hits, walks, strikeouts, the rest of the stats. We could go ahead and make predictions based on it.
You don't know the formula. Is that a better?
Yeah, that's a more realistic. If there wasn't a formula that was simple and you only had the rest of the data, yeah.
Because I would just calculate the OPS.
Yes. Yeah.
So you're saying, assuming we don't know how to calculate it, how do we take the numbers in here and get the OPS?
Exactly. Yep. Any more questions about this first example? So again, the libraries used here, I mentioned pandas. That's the data frame library. Scikit-learn, which is the science kit, right? It's the machine learning kit that's in Python. It's just one of the most widely used libraries in machine learning and artificial intelligence. And then XGBoost. XGBoost is the gradient boosting library. There's a website called Kaggle where there's lots of machine learning competitions, and XGBoost libraries solutions tend to win every time there's a problem that has to do with tabular data. And the way that the library works is it's really just making decision trees, right? It's pretty, conceptually, it's pretty simple to understand. It makes a decision tree. From there, it's like branches out into different decisions, and it just figures out, right, based on the decision tree. And so that's what the model is it's just making decision tree. And it goes, well, that one didn't make a very good prediction. Let's try a different decision tree. And it just learns what decision tree to make in order to make the prediction. Anything else about this one before we move on to example number 2? Okay. The second example is, this one is really interesting and a little bit more complicated than the first one, right? So, and the example here is, I haven't coached before. I'm not good at calling pitches, right? How do I know? Should I call a ball or a fastball? A curveball, a changeup? Should I actually have the pitcher try to throw it for a strike or try to throw it for a ball? Right? Because the pitcher doesn't always want to throw a strike. If they're ahead in the count, no balls and 2 strikes, they might want to throw a ball and try to get the hitter to chase. So we want to see if we can train a model that can learn what's the best pitch to throw given the current situation, right? So we're in the 5th inning. There's 1 out. There's a runner on first, and the count is 1-1. What pitch should this pitcher throw next, right? So that's training in AI to learn based on a real-world situation. So again, I will come back to this tasks page over here and say, this is sort of tricky, but given a lot of choices here, can anyone guess what sort of model you would want to use to do this? Right, and multimodal is combining vision and text or text to image or whatever. NLP is natural language processing and all the different things you can do with text. It's not a computer vision problem. It's not an audio problem. It's not tabular. It's reinforcement learning, right? Reinforcement learning is the idea that we can have an AI model, right, that learns based on rewards. So it's essentially like a kid does something good, here's a cookie, right? Oh, hey, that kid's going to do that behavior more, right? Hey, you do that behavior, we're going to take your allowance away, right? Oh, that's a penalty, right? So there are only rewards, right? Positive and negative rewards. And so you can write a function that's a reward function, and then you can train this model based on that reward function to learn. And so we're using something in this next example of reinforcement learning. We're using something called deep reinforcement learning, right? Which just means that it uses a neural network. But it belongs to the reinforcement learning like family of AI problems. So and let me make sure.
Real fast.
Yep.
Can I get you to maybe zoom in your screen a little bit?
Zoom in or zoom out?
Zoom in. Make it bigger.
Yep. Is that better?
If that's gonna help,
That helps.
Okay.
What is unconditional? Go back up. There's one of these models. If you can scroll up, unconditional image generation. What is that?
That is new, and I actually don't know the answer. But if we click on it, unconditional image generation is the task of generated images with no condition in any context, like a prompt text or another image. Once trained, the model will create images that resemble its training data distribution. So there's no prompt. It sounds like you give it an image or some images, and it will make other images that resemble it.
Okay.
Yeah. Okay, so let's dive into the second example, which is practice calling pitches. Let me just make sure I jump to the right. Yeah. And so we're using a library here called Stable Baselines 3. There was a Stable Baselines. I'm not sure. I assume there was a Stable Baselines 2. But
can I get you to?
zoom in again.
Yeah.
Yep. What's funny is I normally work at about this size. Is that better?
Yeah, a bit.
Want me to make it bigger, or is that?
If you can go bigger without.
Oh no, we're gonna roll off there.
Yeah,
Yeah.
that's fine.
Okay. So in this case, right, I have a model, like I can train a model, save it off to a file so that model can be used later on. And then I can load that model, and then I have some sort of current game state, right? And initially it'll be, it's the first inning, the score's 0, there's 0 balls, 0 strikes. It's the beginning of the game, right? And I have to tell it, this game state, I tell it, who the pitcher is, who the batters are, and the defense. And so let's go look at how you represent things in machine learning, right? How do I represent a pitcher and a batter and a defense and all that? Well, pitcher, right, is basically we want everything to be numeric. So we have to work on taking whatever it is in the real world that we want to represent, and we give it numbers. In pitching, it's kind of conceptually fairly easy, right? Because I can think of this pitcher has a really good fastball. They throw 90 miles an hour, and they can command it. They can put it where they want. They can locate that pitch. So I'll give them a rating of an 8. Right? Their curveball is not so good, they get a 3. But they don't throw a knuckleball, so they get a 0 there, right? So we can go ahead and give these ratings. The same thing for, how good are the batters? Well, some of the batters are better than other batters. You can think of that roughly as like their batting average. And then how good is the defense, right? Is this a really good defense, right? The outfield run down every ball, or do they make errors all the time and they would have a low score? So whatever the thing is that you want to represent, essentially, you're going to convert it to numbers or arrays of numbers, right? And that's because that's what these models require as inputs. So we have this environment, and then we just go ahead and simulate a game, or we can go ahead and train the model, right? So there's simulate a game is running the model, and then we have a different learn to pitch over here. This is where we train the model. And so this one is, we're using the PPO algorithm. We go ahead and we learn, and we tell it like how many iterations or time steps do you want to take, right? So if you can undertrain a model, so if I say, just go ahead and try 100 different like iterations of training the model, that model is going to be really awful, right? It's going to be undertrained, it's not going to know what to do, and it's going to seem like you're just getting random results.
What is it training on specifically? Do you have like a slew of like data?
No, it's training on that reward function. So there's a great question. Okay, so there's two concepts in reinforcement learning. There's the concept of an environment and the concept of the reward function. And so the environment, and then there's also the machine learning algorithm, right? So the machine learning algorithm looks at the environment and makes observations, right? So it says, I see that it's the third inning and the count is 2-1, right? And this person's up to bat and this person's up to pitch, right? I see the state of the universe, right? The state of the environment. Based on the state of that environment, right, I'm going to choose an action, throw a fastball, throw a changeup, whatever that action is. It's going to use the reward function to figure out what should the reward be given the current environment and the action taken. And then it's going to figure out, it's going to learn which actions to take based on that reward function. Oh, that was a good action. I'm going to do more of it in the future. Oh, that was a bad action. I'm going to do less of it in the future. So those three simple things, right? The algorithm, the machine learning algorithm, which in our case here is PPO, right? And the environment, which is the game state. That's the state of the world, if you want to think of it, the observable world. And then the reward function.
And these are, I guess what I'm trying to get at is these are like well-defined constructs, because I keep hearing about how LLMs or AI are hallucinating.
So, so LLMs we're going to get to later. That's one of the other 9 examples. So this is reinforcement learning. So it does not have hallucinations in the way that the LLM does. LLM is doing generation. We'll talk about that in a few minutes, yeah. So the hallucinations, by the way, in real life they're a serious problem.
So basically, you're training the model here, right?
Yes. So
An LLM's already trained, right?
you can train your own LLMs too, and we'll do that. There's something called RAG, right, where you can take an existing LLM model, you can add your own data, and you could train a new model and use that. Or you can use the model. You don't even need to train the new model. You can use a model and your own data and get answers. And so that's a really popular way to operate, because that way you don't need to give your data to a third party to have it train a model for you. You can have your local data, have a more generic model, right, and operate that way. So, right, and now let's take a step back, right? Let's go back up to the 10,000-foot view, right? Remember I mentioned there's 9 examples. There are 9 obviously different sorts of examples, right? So the first one we were looking at, hey, if I have tabular data and I want to predict one of the columns, this is a good thing to do, right? This one is, hey, if I have something and I want it to learn and get smarter over time, I can use reinforcement learning. This is a different type of machine learning, right? And so an LLM is yet another type that we'll cover as one of the 9 examples. So there's lots of different, yes?
I think you just answered the question. Chat he's saying something about rewards. Is he referring to reinforcement learning?
Yeah, the reward function is so the reward function basically takes in the environment and the action, and it says, it comes up with a numeric reward, right? Saying this was like positive is good and negative is bad. And so, what might be helpful is if we look at the reward function is in the environment. So rather than, it's important to understand the concepts here, but at some point down here, right, every time we take a step, right, like another iteration in the training, that's called a step. It tells us, hey, the machine learning algorithm said, take this action next, throw a fastball, right, whatever. And so we go ahead and we have to calculate the reward for that action given we're in an environment. So given the state of ourselves, the current environment, if this action's taken, what would the reward be? And so in this case, right, I figure out what the outcome of that pitch would be, right? Because just because someone throws a fastball for a strike, it could be a called strike, it might be a swing and miss, it might be a hit, or it might be, the ball might be hit, but it's a pop fly and it gets caught, right? So I go ahead and figure out all of those different things here in this code, right? Say, oh, okay, well, what was the outcome of it, right? It was, they get penalized if they throw a knuckleball. But hey, this pitcher doesn't even have a knuckleball in his arsenal. So the reward is negative. You get penalized. Hey, don't do that, right? If the pitch is a ball in play, if it's a hit, well, that's not good for the pitcher, so that's a 0. If they throw a ball, that's better than giving up a hit, arguably, right? Because it's not automatically a player on base until they get to 4 balls. Then they get rewarded more if it's a strike, and then they get rewarded even more if they throw a pitch and it's hit and they get an out in the field, right? Because strikeout takes 3 pitches. Sort of the best outcome would be, hey, I throw one, they pop it up, and we catch it. I throw one, they pop it up, we catch it. We could get out of the inning in 3 pitches. So they actually get the biggest reward for that. And so I calculate these different outcomes, and then up here are the actual, I adjust this, right? As I'm training the model, I need to say, oh, that model is not very good. Let me adjust the reward function so to see if it can learn. So, right, I heavily penalize, excuse me, for example, if they throw a knuckleball and it's not in the pitcher's arsenal. I'm not interested in the AI telling me, throw a knuckleball. I'm like, oh, in real life, that's not going to be helpful. If we give up a hit, they get a negative. I actually give them more of a penalty for a walk than just throwing a ball, et cetera, right? So these are the versions that this was trained with, yes?
So if I understand correctly, you're training a coach or a tool for a coach who's going to tell the pitcher what pitch to throw. So you're teaching it, hey, if the pitcher doesn't even know how to do that kind of pitch, that's a really bad choice.
That is perfect. And also it segues into my third example, which is now using this model that we just trained in game as the coach. So, because that's exactly, you're 100% hit the nail on the head. That's exactly what we're talking about here. So the very next example is, okay, that's great. We trained this model, we used it, but now I actually want to use that model during the game, right? So we're going to see here that this one is in a loop, right? It's going to say, hey, tell the pitcher to throw this pitch. And then as a coach, I'm going to put down the sign, right? Throw a fastball, right? Or whatever our signs are. The catcher's going to relay it to the pitcher. The pitcher will throw the fastball. I'm going to type in the outcome of the play. It was a ball. It was a strike. It was a whatever, right? And then it's going to update the environment and say, oh, great, that was 1 ball and no strikes. Okay, and it's going to tell me now, based on the new information, the new environment, right, the updated environment, here's the next pitch to throw, because that's what the model was trained on. Now this model in real life, this particular model is probably a little bit undertrained, so it's not amazing, but let's go ahead and run it. It's not practice calling pitches. Where is this model right here? So this is an example, and now I want to clear this out. So when I do this, when I run this I legitimately could do this, right? As a coach, I could say, hey, I want to run this AI during the game and actually have it call pitches, and then I signal them into the catcher. So, and I print out stuff in yellow, right? So the first thing that I had this AI do is say, you have 7 pitchers. Tell me who the starting pitcher should be, right? And so I use Anthropic here. This is a call out to a commercial API. But you send it the information on the 4 pitchers that are available, and then I told it, explain yourself, why you chose the pitcher that you did, right? And says, I said pitcher 3. And then I told it, at the very end, give me the index of the pitcher that you chose, so that I can just grab the last line and then take that, and then, I know I have 4 pitchers, so it chose pitcher 3, that's index 2, right, because it's 0 indexed. I can go ahead and do that. And so it tells me, right here, I want the pitcher to throw a slider, and I want him to throw it for a ball. We're going to we think the batter's amped up. We want to see if the batter will chase the first pitch of the game, right? And so I'm going to say, oh, that was a ball, right? And so it's going to update, and you can see all this stuff printing out as it updates. And now we see here, right? And this is just printing out the updated game state inning, right? There's no outs, 1 ball, 1 strike. Right? And then I can say, because I'm using Anthropic, I don't need to choose. I'm using an AI to interpret what the user types too. So if I say swing and miss, that should come back with what? Right? I didn't say ball, I didn't say strike, I didn't say hit, I didn't say out. I just said swing and miss. So is Anthropic smart enough to understand, oh yeah, swing and miss is a strike. So now the count is 1 and 1, right? And I'll go ahead and I'll say, next was a pop out. Oops.
Does it understand if you hit by pitch?
I did not put hit by pitch in there, but I could. Yeah. There's a one of the things that I have in here is like sort of the rules of baseball and like what valid plays are and things like that. So it has only ball, strike, hit. It only has singles too. Right now it doesn't have
It's
doubles,
not-
triples, home runs.
It's also not calculating, like, based on statistics or anything, what the result of the play is, you're telling it.
In this particular case, oops, sorry, hit the mic. I'm telling it, yeah, because this is me using the AI in game, saying like, hey, here's what happened in real life. And so now we have this AI that's telling us, hey, call this one, and it just happened to look right. I didn't see what the earlier pitches were, but oh yeah, this is probably an undertrained model, right? Because it just keeps telling me to throw sliders for a ball, but we're getting good outcomes with it. So right, we got a strike and out so far. So it's probably going to keep doing that. And then, there's various things. Right? It knows that there's 4 pitchers. It also checks, I should mention this, after every pitch, we can have it do things like check, like, hey, should we pull this pitcher? Right? It can make more than one decision, right? It can, we can have it do sorts of things, which we'll cover that a little bit later on. But this simulating here is just saying like, hey, here's the best pitch, right? The AI recommended pitch to throw, and then reality hits, and who knows what happens. We observe it, and then we type it in to update the state of the environment that uses the model to figure out the next action. Yes.
So you're saying about maybe being under trained with, say, slider for a ball. If you were to type in hit, it might change its mind because maybe slider for a ball is going to work. It's a little hard to
Yes.
tell just from that. Just in the limited example space you have. Same thing. A lot of course of baseball not in here, obviously.
Yes.
So, but if you did say hit, maybe it would change its mind. Maybe the right thing to do is this one thing until.
That's right, and it all depends on. So once the model is trained, I should point out too. There's another little detail in here when we run the. No, that's the environment. Sorry, let me go look to. And I made everything. This right here. So when we pass in deterministic true, when we make our prediction, we also, basically that's telling the model like, hey, based on all the things you've learned and given the current environment, like like this would be the sort of best choice. You also can have it have some amount of like randomness in there and say like, yeah, don't always choose the best one. So if I was to set deterministic equals a false, it would also still have some variability. So even though it's like, hey, the best pitch to throw here is a fastball, when you do training, deterministic is true is obviously not a thing, right? When you're training, in order for the reinforcement learning algorithm to learn, it needs to have variability in it and needs to try some kind of wild things. Right, and it does that, and it learns, yeah, that was good or that was bad, right? But yeah, so making these predictions, it's training the model, right? We've trained the model, and based on the reward algorithm, and now we're using the model, and we have the environment that we update, and then it tells us what action to take. We update the environment based on that action, and then we tell it make another prediction. And so it's just a pretty tight loop of make the prediction, right? Get back the observation, right? Like that's the updated state, if you will. And then we loop back around, right? And we go ahead and pass that into the model, right? And it's going to update the model with that observation and then make another prediction. So. Any questions about this? And like I said, I'm not going to deep dive into every single line of code here. This stuff's all available on GitHub. This is more about introducing everyone to like, hey, here are the different concepts, the different types of models and when you might use them. I did skip over one section here. So let me just go back really quickly. Let's run this one very quickly, and then we will get to, and I can type game over here, and we can go ahead and end that game. So one of the other things is, what if one of the players right before the game calls and says, I can't make it to the game today, I'm sick, right? Well, I had 9 hitters in the lineup, and I need to choose one of the other hitters that's the most similar to that hitter so I can put them in the lineup, right? And so I have this recommend similar hitter. This is looking at the data of the hitters, right? And in this case, right, I've told it to find the most similar hitter to Ryan because Ryan can't make it. And it says, oh, Dylan's the most similar than Benjamin, then Ben, then Miles, then Noah, right? These are the most similar hitters to Ryan. And so therefore, I would probably choose the top guy, Dylan, and say, Dylan, you're hitting in Ryan's spot in the lineup, right, wherever he was. And let's keep going down here. We did the AI calling pitches one. I wanted to show this really quickly. So I mentioned that all of the, not all, but pretty much all the baseball teams, youth and adult baseball teams in the US, they use this app called Game Changer, which was bought by Dick's Sporting Goods. And this is, they have an app, and someone, usually if it's youth baseball, there's a parent who after every single pitch puts in ball, strike, single, double, whatever. And that way there's a live stream, and like grandparents or folks who aren't at the game can actually listen to it. It has fake crowd background noise. It's really cool. It's like my favorite app of all time. But they also, because you enter in all the plays, it keeps track of all the stats. You can see here that you can come in here and you can export the stats to CSV, which is exactly the data that I've been using for all these examples. But what I wanted to show is this app also has a real life example of using AI. So if I go into any one of these games, I have to do it on the mobile, unfortunately, I guess. What they do is they generate an AI news article basically about each game. So there's like this written summary. And so I have some sample ones over here. It's a very cool use of AI. So let's go ahead and look at this. And so I've changed a couple of the names here. Yeah, but you know, it says Thundercats bested the Braddock Bearcats 6-1 on Wednesday at Lake Braddock Secondary School. Thundercats got on the board in the first inning after Ian singled, scoring 1 run. Dylan started on the hill. Like, this is all AI generated, and you actually see the copy right down here at the bottom, which I've left in here, right? So they generate this. Yes.
Do you think it's using an LLM, and does it ever hallucinate and give bad stuff that isn't even real?
Yes, I think it's using an LLM, and I think that this one's pretty good about the not having hallucinations. I think that it's, you know, I forget the name of the company. I think that they use a third-party company to do them. It's somewhere on their website. However, I'm about to show an LLM example based on these. So they're taking the stats and generating a text summary. I'm going to take their text summaries, and we're going to do that RAG example. So we're going to run an LLM, and we're going to use these game recaps, and we're going to start asking questions. And this is where the hallucinations are going to come in. I can tell you right now, at times it's not pretty. And you know, we're using open source models, maybe not always the best open source models. So let's go ahead and, this one I'm not even going to show, but I'll just explain it really quickly. I can take that game recap and I can summarize it, right? It's just one of the other NLP models that was on there, text summarization. So I can take something and give a really short, concise version of it. And so that's less interesting than also game sentiment. I can read the article and say, was to have a positive or a negative like tone to it, right? How did you know people feel about it? That's useful. Sentiment analysis, right, is used in marketing all the time. Like, we put this tweet out, did people like it, not like it, whatever. So let's go ahead and let's run this example right here, and I will make this bigger. So this particular one, remember I mentioned at the very beginning, I'm using in a Docker container of open source vector database. So I have done that. I've converted those recaps into embeddings which is what goes into the vector database, right? And then I have an LLM, right, that's basically answering questions about the articles, which are the embeddings of the articles are in the vector database. So I just said a whole lot. Let's unpack that for a minute. We don't put, in machine learning, right, we don't put things in traditional databases unless if we have data that we just want to store and retrieve, right? Like maybe the statistical data I would want to put in there. But if we have something like lots and lots of text, how can I could do like queries in a relational database, but I can't actually do a lot of similar searching and searching for all these vectors. Remember, they're just like arrays of numbers. And so I need to have, basically a vector store database so that we can store all those numbers. We use numbers to represent everything. So I have all this text. I'm going to create embeddings, which are just numbers that essentially represent that text. That's going to go into the vector store. And then I can query the vector store. And you can think of it as, I think the easiest way to think of it is, instead of a three-dimensional space, think of it as like a multi-dimensional space. And I can query and say, hey, in this multi-dimensional space or in this three-dimensional space, what's the closest thing to this point right here? Right? So if I'm asking it a question, I can calculate the embeddings for that question, which is some point in that three-dimensional space, and say, hey, what's the closest thing that's actually in the vector store to that dot, right? That point in that three-dimensional space. And that will be, or I can say closest or closest things, and it will return those as the results. And so these vector stores are like super important to LLMs. And so I mentioned RAG, retrieval augmented generation, which says as you're retrieving it, also augment your answers with this local data. That's RAG. And so that's another thing. So you can use an LLM with your, like I mentioned, your local data, so you don't have to train a model that always has all your data in it. You can take a model, take your data, and then go ahead and use the model and still augment your answers with your local data. So let's take a look at this right here, right? So I asked some questions, and you'll see here, right, like who was our leading hitter? Based on the details provided in the context, Ben led Thundercats with 3 hits and 3 at-bats, right? It was like, well, no, we gave it 5 games worth of information. So clearly it's only found, like this particular one, it's gone in and it hasn't worked very well because it's answering the question about one of the games, not all 5 of the games, right? And so you would need to be a little bit smarter about the way that you put the data into the vector store in order to really answer questions about aggregated data. But some of the stuff, it can answer. Who was our starting pitcher? Unfortunately, it doesn't provide information, but then it turns around and gives the answer, right? So we were talking about these hallucinations. Now, a real hallucination would be if it said the pitcher was Bob, and Bob isn't even a player, right? That would be like a true hallucination. Yes?
Looking at it closely, it's saying it doesn't have information about the game against the Bearcats, and then it answers about the MVP dogs.
Right, and so yes, so it's conflating, right? Those are 2 different teams, right? It's conflating 2 different games. So saying, I can't answer about the Bearcats game, but I can answer about the MVP game. And so here's the answer for the MVP game, right? And so it's almost like it's falling back to answer B because it can't give you answer A, okay. Right? In this, these things, in the real world, it takes a lot of crafting and manipulating, right? The first thing is you have to collect great data. You've got to do a lot of massaging of the data. Then you have to figure out how to get it into, you have to ask, in general, you have to ask pretty pointed questions a lot of the times, and you have to get data in a format in the vector store, right? In theory, you should just be able to throw anything in there. In reality, it doesn't work like that, right? You need to sort of have, and you can have different vector stores with data that's represented different ways. And so you might have an AI that decides, hey, given this question, I want to use this vector store. Given this question, I want to use this other vector store because it represents different data or the same data in different ways. So there's one final example that I want to get to, two really quick examples that I want to get to. so we can try to wrap this up because I've already gone for quite a while.
That's not a buzzer telling you to quit.
Yeah. Well, it's still a true statement. So what I want to talk about is the concept of AI agents. This is one of those things that sounds so cool. At the moment, a lot of times is falling totally flat on its face, but in 3 years might be amazing. So let me describe the concept and let's talk about what this is. So AI agents is the concept of I have independent running AI, artificial intelligence agents. And those agents communicate with each other, right? And then they do things. So each agent could be an LLM, for example, which when you do every single one as an LLM, it gets really weird. But the first researchers that I'm aware of that did something with this said, let's make a video game software development company. So they created some agents and they said, hey, you are an LLM that knows how to write Python code. Each agent gets a role. You are also a developer that knows how to write Python code. You are a tester that knows how to write tests to check the generated Python code. You are a graphic designer that knows how to generate images for the video game. You are quality assurance. You are the product manager. You are the CEO of the company. It literally did AI agents for every one of the roles. And then there might be like an agent that's responsible for planning that says, hey, here's the coordination. But basically, they did that, and the first pass was let's create an existing video game. Use an AI, right, to create like Pong, something very simple, right? And they used all these agents, and eventually they figured out how to do it. And they wrote this like generic framework, so they have these agents that can write video games. And it went from Pong to being able to do like, Pac-Man, to being able to do more sophisticated games. It's not going to generate exactly Pong. That's not interesting. The point is to generate new games. And so the games that it can generate are getting more and more and more sophisticated. This concept, now you take that concept away from doing video games and start applying it to the business world, right? And this is where things get really interesting. And so this is what we're trying to do for our clients now, is create these little AI agents that do discrete things inside of their business that might be, rather than just have hey, here's an LLM AI assistant that you go type to all the time, we can have agents running in the background checking like, hey, that thing that was supposed to be done, right? Check, was it done, right? Because it can run just a regular old function. It can just run a function that queries the database, says, hey, are there any missing TPS reports or whatever, right? And then say, oh yeah, hey, there are, and then it can pass that information on to another one, and it can make decisions based on that.
So we have a question. Do the agents exchange information like APIs, or do they use federated learning? I don't know what federated learning is.
So it kind of sort of depends on the agent framework. So Microsoft has a popular agent framework called AutoGen. There's one called Crew AI, there's LangChain, and then there's one called Llama Index. So I'll show here in a minute an example with Llama Index. A lot of the times, what like Crew AI tries to do is essentially pass text around. And so what we found in the real world is when you have an LLM that generates text, it passes it to another LLM that reads the generated text, tries to understand it, generates some more text, passes it to another one, it's like the game of telephone, right? And it's worse, right? And so it just tends to fall on its face, right? A lot. So what we have found works much better, and the reason that I'm going to show Llama Index is because Llama Index and some of these other ones, Crew AI and others as well, have something called agentic workflows. And what that allows you to do is, hey, here's a workflow, a general workflow, right? And then you're going to use agents in that workflow. So in the business case, this is really cool because most businesses have some sort of workflow, and you can watch the data sort of flow through the workflow, and you can use the AIs to make non-deterministic decisions in the workflow, right? So it doesn't need to, like I'll show in this example, I've got to make a decision, right? Like back to the baseball example, after every pitch in the simulator, it needs to decide, should I pull this pitcher and put a new pitcher in? Right? Well, I could hard code that and say, if the pitcher's thrown more than 10 pitches and less than 60 pitches, and if they've thrown this percentage of balls or whatever, or I could just write that in English, send it to an LLM, right, and tell it, you make the decision, should I pull this pitcher or not, and tell me the response. And that way I get some non-determinism, which makes it a little bit more interesting, right? I sort of give it the information. What we found is if you give the AIs a little bit of data, so they have enough context, and you give them like simple decisions, like choose one of these 8 options, or those sorts of things, it's pretty good, and it works really, really awesome in these agentic workflows. So we'll go ahead and we'll look at the code for that, and it will be the last example that we will go over.
I mean, you're describing like HR departments, if you ask me.
I was just gonna say, this sounded very, very,
A little dystopian, actually.
hiring process.
So, well,
Does anybody remember the joke about replacing our secretary with a short shell script?
How did that work? I have suspicions.
In the story pretty well, but mindless task pretty well.
so I know a lot of people, right, are worried about AGI and worried about job security in the future and stuff, right? And this is just going to create more work, not less work, because it's also going to generate a ton of buggy code that's going to need to be fixed. So let's go ahead and look at this. So we have this pitching workflow. And so I'm going to go ahead and we're using the same game state environment, the same game state data that I used for the deep reinforcement learning. It knows the innings, the balls, the strikes. It knows the current state of the game. And so I'm going to pass that game state through the workflow. And I'm basically just going to go ahead and run the workflow, right? Start it up. So when we look at this workflow here, right, it starts off with the pitching workflow. In this case, I use an LLM. I could use a local one in Olama. I'm happy to use Anthropic in this case. But I start game, and then it says, well, at the start of the game, the first thing you need to do is choose who the starting pitcher is for your team, right? Okay, great. So it's going to return a choose the pitcher event, right? And I'm going to pass that the game state. And then it's going to say choose the available pitcher. So I'm going to get the remaining pitchers, right, out of the game state. I started with 4. And if there's none, right, there's no more pitchers available, we need to forfeit, the game's over, right? And so I'm going to pass the pitchers. I'm going to have this prompt here. I'm going to pass the information about the available pitchers, and then I'm going to tell it, choose one, give me the index, explain your reasoning. At the end of the explanation, put the new line, right, with only the index without any other text. And so that's going to choose one of the pitchers. It's going to explain why it chose that pitcher, right? Oh, this pitcher has a good mix of fastball and curveball. That should keep the hitters off balance. It actually says something like that. And it doesn't choose the same pitcher every time. It is not a deterministic thing. I go ahead and write, and I get the response back. I just strip off any white space at the beginning and end. I split it, so I just get the last line, convert it to a number, and then I go get that pitcher, right? So they said choose pitcher index number 2, right, which is the third pitcher. Great, I've got that pitcher. Remove that pitcher from the remaining pitchers, update the state of the game, and basically this is setting the current pitcher. And then, this is removing the pitcher from the available remaining pitchers. And then I tell the AI, go ahead and pick which pitch to throw, right? Oh, okay, great. Which pitch should they throw? Well, I used that trained model, that deep reinforcement learning model that I showed earlier, making the decisions one pitch at a time. I go ahead and I've got that model loaded. I make my one prediction, and I tell it, hey, go ahead and throw that pitch, right? When that's done, I have the input required, which says, hey, I'm in the CLI world here. I need to go ahead and wait for the user to type in the outcome of the pitch, right? We already saw that. So there's a human response event after they type it, right? And so based on that, 2 things could happen, right? They've thrown a pitch, it was a ball. We've updated the game state, great. But now we need to say, should I pull this pitcher out, right? And so you're to choose between one of the following outcomes based on the text description. You can, this is interpreting the outcome of the play, sorry. And then they can choose, right, basically hit, out, ball, strike, or game over were the choices. Otherwise, it's an invalid play. In real life, you would probably have it loop back and say like, hey, I didn't understand what you said. Could you describe the outcome of the play again? In this case, right, I just end the game if we get back some invalid thing from the LLM. But I update the state, and then this is what's nice about the workflow is it's not a linear workflow, right? I can branch out, and I could say, well, maybe if the game's over, right? Like if that was the last out of the 9th inning and the score's not tied, the game's over, then I just raise the game over event. Otherwise, I need to go to the change pitcher decision, right? Should I pull the pitcher after that pitch or not? And we come in here, and again, we're using pitchers must not throw less than 10 pitches. They should throw more than 45, not throw more than 45. If they throw 50% balls after throwing 10 pitches, you should pull them. If the pitcher gives up 3 runs, they should be pulled, right? Here are their stats so far, or the current pitcher stats so far. Go ahead and tell me, should we pull them or not, and explain yourself, and then at the end, tell me your decision, yes or no. So we go ahead and we use the AIs to make these simple decisions in this larger workflow, right? And then, right, it's really that simple. But like I said, this sort of thing we are doing for clients in the real world. It's working pretty well. It needs to be for things that are not deterministic. So that's like really important, right? If you want, it must, if the pitcher hits, the rule says the pitcher hits 85 pitches or whatever, you must pull the pitcher. We don't want to ask an AI that, right? If they have 85 pitches, that's a deterministic thing. We must pull them out of the game at that point. And so we would want to write a function that said if the pitch counts greater than or equal to 85, pull them from the game. Else, go ahead and ask the AI, should I pull the pitcher or not, right? So you need to have this mix of deterministic and non-deterministic. And we found that these workflows offer, in a real life software example, they offer the best of sort of both worlds, melding of the two worlds together. Any questions about the agents? Okay. Like I said, the code is all available on GitHub with all of the tools that we learned or that we used. Right, I've mentioned sort of some of the big ones. XGBoost was good for tabular data. Stable Baselines 3 is a good library for deep reinforcement learning. Pandas is a big one. Sentence transformers, I didn't talk about that, but that's the library that takes text and converts it to those numeric encodings that go into the vector stores. So it's a library just for that. Llama Index is what we just used for the agentic workflows. Anthropic is the commercial LLM that we were just using. It's API. Hugging Face is the website with all the open source models and data stores. The sentiment, I didn't actually run it, but I think everyone gets the concept of that. There's an open source vector store that we use was Weaviate. They have a commercial cloud offering too, but I'm using the open source version. And the final one, I guess maybe I should show this really quickly. This will be the very last thing that we do. Let's go ahead and run this. So what this is a library called Streamlit, and this allows you to create a website using a Python API instead of having to know. And so it's designed for websites to show off machine learning results, right, essentially, right? So I can do things like in the hitting stats, I didn't make this pretty, but those pandas data frames, I can just say, hey, go write this data frame to the web page and just hand it the data frame, and it knows how to put it in a table and how you can do charts based on those data frames. And so if we look at this hitting stats file, really quickly over here under Streamlit, pages, hitting stats. This is just one library, there's other, but basically Like I have a data framework, I could just say with that line, hey Streamlit, give me a line chart of that data frame, and boom, I get a line chart on my website. And there's like tons and tons of components. Under examples, it just has just a few of them. I'm going to allow that. So it has all these different things, so you can have buttons and forms and all the typical stuff. But it even has like real-time camera. I don't know where that. Yeah, there. Right, so you can do like capture audio, capture video. You can do some really cool things, not just show charts and tables and whatever. So.
And you can chat with them.
Yeah, so you can put an LLM in here, like on the left. This is an Echo LLM, so it's not interesting. But you can have it's a component designed to have a chat interface with an LLM. Right, that's like a built-in component in this library. So I just wanted to show this because if you're doing machine learning, at the end you usually need to present it to a client or present it to someone. This is a nice way to nice, quick, and easy way to take your data frames and show charts and tell the story. Right, build a website to tell the story that you want to tell. So, all right.
Question.
Yep.
If I didn't want to use VS Code, what are my options?
For editing code, for
Yeah.
Python, or for specifically, or
Language, but like if I wanted an AI to help me with coding, and I didn't want to use VS Code, what are my options?
oh, I mean, you can use really those like Copilot. What you're choosing between is Copilot versus another code generation. So in that's what matters to me. I don't know if they show it here under tasks, but one of them, if we go under models, and I type in code.
So to your question specifically, I know that there are some AI plugins for NeoVim. So if your text editor of choice is Vim, you can use that. By some bizarre occurrence, Microsoft updated Notepad recently with Copilot because when you just need to open a quick text file, you need a AI scraping it for some reason.
So I mean, basically, yeah, it's sort of orthogonal, right? It just is there a plugin in your text editor, whether it be a command line or like a GUI, it doesn't really matter. So there are open source models on here for code generation. One of the very first things that one of our clients had us try, for example, is they said, our people are tired of filling out this form to search for data. They want to type in here, go get me all the people that have a PhD that are experts in this subject. They type in that English, and we take that text and generate a SQL statement and then run the SQL statement. The problem is our database has like 500 tables, and it's hard to get that. So what we had to do was some views with simplified views of the data that they were likely to ask about. So it worked, actually. Most of the time. Some of the time it doesn't work. But back to your question, it's as long as the text editor has a plugin, what really matters is what LLM are you going to use for the code generation? Are you going to use Copilot? Are you going to use one of these open source ones? There's a bunch of other commercial ones, and some of them are really, really good too. I just happen to use Copilot.
I happen to get Copilot working in Emacs on OpenBSD as sort of exercise try to achieve open source purity. It can be done. You can find tutorials. It takes a little tweaking.
Yeah, it's any other questions? All right. Well, thank you all so much. I know that was a pretty long one,
No,
but
it was great.
we showed a lot of different. Hopefully, it introduced you to lots of the different things that can be done. So, thank you.
Yeah. Thanks, Bryan. All right, I think we can stop the streaming, and then next month, remember Install Fest? Actually, I don't know why I'm holding this. If we stop the stream.